Hello everyone, in this video you will learn how to find uncertainty for the gradients in intercept. But before you are able to do that, you need to first know how to find the gradient and the intercept without uncertainty. And gradient is another word for slope, and slope just kind of help you review here is rise over run, so y2 minus y1 over x2 minus x1. I'm expecting that you should know how to find that before you taking either IB physics or Saturday physics in high school. X1 and Y1, just again remind you that it's the coordinate of the first point in the line, and X2 and Y2 is the coordinate of the second point in the line. And intercept, the one that we will be referring to for this particular example is the y-axis. This is the point where the graph crosses the y-axis where x equals to 0. The uncertainty for the x components that I will be using is too small, so we just ignore that for now. And just a reminder again is that the equation of a line is y equal mx plus b, and m is referring to the slope of the line, and then b is the y-intercept if you set x equal to 0. So let's make up some data so we can graph it. We have time and distance. Distance, I'm going to put it in the y-axis, and time I'm going to put it in x-axis, and now I'm going to plot all the data points onto this graph. So this is something I expect you to know how to do already, and this is the best fit line. Usually the best fit line, you use graphing calculator to find that, or Google spreadsheet or Excel. You can also do it by hand, but when you do it by hand, just make sure you try to hit all the data points you can. In the case in which you cannot hit all the data point with the best fit line, the displacement between the data points and the best fit line should be minimum. The average displacement of all the data point to the line should be minimum. That's how you draw it. For physics class, I don't expect you to draw by hand, but in the case in which you take an IB test, they require you to draw it, then you should know that's the criteria for drawing the best fit line. It's the minimum displacement between the data points to the best fit line. I know I'm repeating myself, but hey, if you hear it 1,000 times, hopefully you remember. In the previous video, you learned how to draw arrow bars, and as you can see here, the time has uncertainty of plus or minus 0.5 seconds, and the distance have uncertainty of plus 5 meters. And that's so I also create a rectangle shape, actually kind of square, rectangle-ish. Is if any point that fall within this region is uncertainty region. So as you can see, the best fit line actually hit all the data points within its uncertainty area. Moving on, so not complicated so far, right? So let me shrink that image so I have more room. So to find the gradient uncertainties, you just take the maximum gradient minus minimum gradient divided by 2. If you're not familiar with the word gradient, just replace it with the word slope. So you need to find the maximum slope minus the minimum slope divided by 2. And so this is just an approximate of the uncertainty for the slope. And in college level, you definitely will do more advanced error analysis. But for now, as a high school level, it's good enough to approximate uncertainty this way. But do know whether we over approximate, and it's always good to over approximate the uncertainty than under approximate. So just keep that in mind. Your analysis skill will get better in college. So I remove the graph and I just keep all the data points right here. I'm going to show you what most people do when they're trying to find the maximum slope and the minimum slope. So usually what most people do is they remove all the data points in the middle like that, okay? And so they just draw a line from this bottom corner, right corner here to the upper left corner of the last data points, okay? And that, as you can see, the slope is quite steep, so that's maximum slope. And then if they take from the corner of the upper left corner of the first data point to the lower right corners of the last data point, that would give them the minimum slope. And so now if I put in other data points here, you notice that the maximum line um, go through other data points within the uncertainty and also the minimum gradients. All right, so the problem here is that way work most of the time, but in a case in which you have the data point, as you can see, this data point is not located right there, but it's down a little bit. The method of using this corner going up to that corner to find the maximum gradients doesn't work well anymore because you're missing this data point, right? So in that particular case, that's why you don't eliminate all the data point in the middle. You have to look at overall data point, making sure that the maximum gradients or the minimum gradient should hit or go through all the uncertainty. And I just moved that maximum gradient line down so it match with it hit this data point uncertainty. Okay, so be aware of that. The previous method work most of the time. However, in some situation where you have to really consider all the data points. Okay, so to keep everything simple, let's just use the data point that I have and the method that most people use. It apply for this case, so we're going to use it. The middle line is the best fit line again. This is max, that's min. Okay, so what is next? Again, just some quick review. We need to first find the maximum slope, and slope is represented by letter M, and then it just writes over on y2 minus y1 over x2 minus x1. And so I have this starting out with y2. Y2 is up here, which is 65, and then you have y1 is over here, so you get 0, right? That's 0. And so this is x2, see that? That's x2. X2 is 7, I'm sorry, x2 right here, so that would be 7.5, right? And then you have x1, the second data point, x1 is 1.5 right here. So pretty much in order to find the slope, you just need 2 points to find the slope. I'm using the coordinate right here and the coordinate right there to find the slope of the maximum gradients. And my answer, when I subtract and divide, I get 10.83 meter per second. I need to round that up to 11 meter per second because I know that my data point is not that precise to 2 number after the decimal. As you can see here, the precision is plus or minus 5 meters, so that will pretty much dictate the whole entire uncertainty propagation. So I round it up to 11 meter per second. Again, same method for finding the minimum slope. Minimum slope, then you just look at this this line right here where say minimum gradients, right? And then you just pick the coordinate right here and the coordinate right there to find the slope of that particular line. And when you do that, what you happen is you get go through, plug in some numbers, and so you get 5.63, and so I round up to 6 meter per second. All right, so the gradients of uncertainty or the slope uncertainty is, we're doing the same method over and over again. It's taking the maximum slope minus the minimum slope divided by 2. So we have 11 is what we found the maximum slope to be, and then 6 minus 6 is the minimum. So subtract, divide, and hopefully I put this in the calculator correctly. You get 2.5, and so I round that to one significant figure. It's that 3 meter per second for the uncertainty of the slope. Gradient uncertainty is plus or minus 3 meter per second, and that would be your answer for this first part of the video. So the second part of this problem is we need to find the intercept uncertainty. the same method again, maximum intercept minus minimum intercept divided by 2. And again, this is the approximations. It's not it's overestimate, over approximate a little bit. But again, this is high school course, so we keep it simple this way. So I'm going to write the equations of the line. So the equation of the maximum line is y max equal mx plus b, just the same equations for max and for min, right? So how do I find intercept? The intercept is represented by the letter b right here. So we just need to plug in numbers. We know that the y for the max is 65. The slope for the max is 11 meters per second. And we have x is a value, which is 7.5. We just plug that in. And so y min is 55. And then the slope of the minimum line is 6 meters per second. And x coordinate that we're using is 8.5. And so as you can see, you have one equation, one unknown for each of this. So it's easy to solve. So I just plug in the number like that. Okay, now we just need to solve for B max and B min. Hopefully you know how to do that. Okay, so B max, just move this over and that could get you minus 17.5 meters. And then B min is equal to 4 meters. Again, using the same methods to find the uncertainty, I just take the maximum intercept minus the min divided by 2. That would give me minus 10.75. So I round that to minus 11 meters. And so the uncertainty would be a plus or minus 11 meters. And that would be your final answer. So the question then is, hey, okay, now I know how to find the uncertainty of the slope and I know how to find the uncertainty of the intercept. In what situation will I be using it? Well, if you think about sometime in physics, you are collecting some data for maybe time and distance. And the cool thing is when you take distance over time, which is rise over run, that will give you the information with regard to the speed of an object moving. So when you graph it, you can actually, the speed of an object at, I'm making up number, at 6 seconds is 40 meters per second plus or minus 3 meters per second, right? So the slope tell you the velocity. For this graph, the slope will give you the velocity or the speed of an object moving. And if you have a numeric value for an answer, there must be uncertainty associated with that. All right? So hopefully that makes sense. And with regard to the intercept, and sometimes depend on the experiments whether you're interested in intercept or not. But sometimes looking at intercept can give you a lot of information with regard to whether you did the experiment. Well, sometimes when you look at the intercept, it can tell you whether you have some kind of systematic error or not. For example, if you know for sure that the y-intercept should be 0, and you know that the maximum and the minimum, the range of that is the 0 doesn't fall within this range, then you kind of know that there's some kind of systematic uncertainty going on, and you can go back and try to see if you can find what's wrong with it. And if you know that the 0 is not within this range, then you know might be not a linear correlation between all the data points. The other thing is maybe your uncertainty approximation is maybe too small. You pick that. Okay. I know I have given you a lot of information, so let me sum it up. Everything again. So the purpose of this is for you to find the uncertainty of the slope of a line and uncertainty of the y-intercept of the line. Okay, and to find the uncertainty of the slope of the line, you just take the maximum slope minus the minimum slope and divide by 2. That's pretty much it. And then you just and then to find the intercept, again, you just plug in as coordinate for the max and the min, and then put in the slope. Then that will give you the slope uncertainty. That's pretty much it for this video. Have a wonderful day, everyone, and I will see you in the next video.